want to have a good laugh with me, come join me for my next talk. But now we're trying to actually get still serious about mgwt and GWT Phonegap. I think probably over the day you come to know who I am. But still, for people that might have just joined now, my name's Daniel. I practically invented mgwt, and I do work on the GWT team at Google. And yeah, I've done mgwt and GWT Phonegap, and I have a lot of fun doing this. Today, I want to actually introduce you to Phonegap and GWT. Sorry, mgwt. Probably you do know GWT. Short hands up. Who already knows mgwt? Okay, that's good. That's the introduction. Who knows Phonegap? Okay, great. I'm also going to talk about an idea that I've been following for quite a long time, actually, and that is building things once in Java and not building them all the time again. And then I'm going to tell you about what I think should be done with mgwt and GWT Phonegap. So let's kick it off with Phonegap. I'm not going to go into much detail here. I'm trying to be as quick as possible. So if you're going to do Phonegap, so what's a good idea to do Phonegap? And basically you can introduce it to people like this. If you want to do software for these vendors, you have to deal with their different OSs. And you have to deal with their different languages and APIs. And that's kind of a problem already. Because as soon as you've done that investment of learning all those different platforms and languages, you have to redo it again because they keep constantly changing. And I look at this as a web developer as a big fail. Because there's a much better way of bringing software to almost any platform without caring too much about the platform details, and that's called the web. And that's exactly what Phonegap does. It uses web standards, puts them in a container, and makes them accessible everywhere. So if you compare native development to web development, it basically goes like this. You're having high development costs because you have to do things all over again because you don't get any portability. Things you're doing for Android, you have to do them all over again for iOS. That's why you have a slow development process. But on the other hand, you're getting good performance. You can call any native API, let's say, reading the accelerometer or the compass. And you certainly can be in any app stores because that's what companies that actually have app stores want you to do. On the other hand, if you're doing web development, you do have fast development cycles. You have lots of people out like you who already know how to write web applications. Therefore, you have low costs. You get all the portability. Things you're going to do that run in Chrome on Android most likely are just going to run fine on iOS as well. But there's a problem. There's a problem. You cannot call any native APIs, and you can certainly not be in any app store. The performance is actually green here, just because if you know what you're doing as a web developer, and if you keep your attention high at performance, you can have the same performance that a native application can have. But as soon as you put Phonegap into it, things change. Because Phonegap is a so-called hybrid, so it's a web application and a native application at the same time. And that means with Phonegap, there's a really big promise in the room, and it says, well, we build stuff once. Then we use Phonegap as a container and wrap our stuff in that container. And that container then allows us to run anywhere. And running anywhere really means running anywhere. Across all those different platforms, you're getting a consistent API for reading the accelerometer, the camera, the compass, and so on and so forth. Actually, that list is much longer. You can get that same approach to work on different places. And that's Phonegap in a nutshell. Let's quickly take a look at how it actually works internally. So every Phonegap application has two parts. It has a web part, and it has a native part. And in the web part, you're having the so-called native web control. And that's the place where you're just going to stuff all your HTML, CSS, and JavaScript. On the native side, you have the so-called Phonegap plugins. And don't confuse them with browser plugins. They're just plugins, and that's just a name for stuff you could call. So the API I just described, that's actually built up from several different Phonegap plugins, like the accelerometer, the camera, and so on and so forth. But You can also write your own plugins. So this means you can write any native code that you want to write. Of course, you have to do that once for iOS, once for Android, and so on and so forth. But having these two paths is pretty much, doesn't have any value in itself. They actually need to be able to speak to each other. So there's a so-called foreign function interface. I'm not going to go into detail of how that communication mechanism works. There's a lot of talks out there on the web, a lot of them I've done myself, that actually explains this whole mechanism in detail. If you're interested in this, it's a pretty slick implementation. It's actually getting better over the years. So that's how Phonegap works. On the other hand, you're all GWT developers. But let me, despite the fact, point out a couple of things that are really well in GWT. So there's this compiler that is pretty much able to put things together really well. And if he puts those things together, they end up being really fast. And on the other hand, on mobile, we do have those incredibly slow CPUs. We're having this incredibly slow network connections. And last but not least, we're running on batteries. So doing unnecessary stuff, not optimizing on compile in advance, means we're just going to drain the user's battery and leave them in a poor state. And as it turns out, because we use GWT in Google Production, we care about all these things. We've optimized this thing now for 7, almost 8 years, and made it as fast as possible. And that's really great for writing mobile applications that are based on the web. The only problem today is if you want to use Phonegap, which is a great idea, and you want to use GWT, which is really good at performance, there are certain things missing. They're missing a good set of mobile widgets, that's mgwt, and the actual GWT Phonegap API to be able to call Phonegap from your Java, from your GWT application. That's actually all I want to do to introduction in terms of Phonegap. So let's drill quickly into mgwt. Well, mgwt has this set of widgets that basically look like a native application would look like. And they, performance-wise, they feel like a native application. So on an iPhone, they look like an iPhone application is supposed to look like. But the real true thing is if you put them on, let's say, an iPad, they look like an iPad application is supposed to look like. So I'm just going to skim through here. And if you put them on an Android phone, they look like an Android phone is supposed to look like. That doesn't mean that you should be taking those themes. It just give you an idea that they can look as native and as good as normal other widgets. You should, of course, roll your own stylings. And it's pretty easy to do with GWT. But there's actually so much stuff in there that I cannot go into detail on all of these. But there's always one thing you should be thinking about, and that's performance. And for this, we can dwell it for about 5 minutes. That's worth it. So on mobile, we do have these slow network connections. I'm talking, let's say, 4 kilobytes a second with a latency of 5 seconds. You all know these connections. We still have them here in Central Europe. And they're all over the place. So size tends to be really important. And bigger is not always better. And when it comes to JavaScript size, 4 or 10 kilobytes more, they actually matter a lot here. This is seconds for your users waiting. And having an optimizing compiler, which is really good at code size and is good at dead code stripping, that is going to help a lot. But there are other things in GWT that help a lot here as well, like perfect caching, making sure that resources you've once downloaded don't have to be re-downloaded again. And I think there's probably one notion in GWT that no one else does it that good and that automated, and that's automated code splitting. So why put everything in the first download if I can display a page to the user and then download the rest in the background? So with GWT, you can just split up your code with split points, display that first screen, the user can already do something with your application and download the rest in the background. But since the GWT compiler knows about all your artifacts, it can actually take a look at them and generate a manifest file for you so your application can go offline. So there's actually a linker in mgwt that does this. Another important thing is getting your styling right. So if you look at this slide, displaying an mgwt application, there's no image in there, nothing. The background, the slider, even that pointy stuff for the button, that is just CSS. And now imagine the difference between downloading a couple of kilobytes of a PNG file to specify that background, or just having a simple linear gradient statement in there. That's massive. The other thing you need to get right is having minimal markup. So why is minimal markup important? Well, everything the browser parses as HTML, it puts that into the DOM. Everything in CSS terms, it puts that into the CSS tree. To actually be able to paint anything, it cannot paint trees. It has to match those two trees to construct the render tree. And then actually lay out that render tree and then draw that to the screen. So the bigger your DOM is, the more work the browser has to do. And this is why it's really important to have a slick and small DOM. If you look at your DOM, it should make sense to you. You should be able to read this and basically tell what the application is doing. So I've taken one example here, that's the mgwt slider, which is probably one of the biggest with 3 DOM elements. Most of them have 1, because that's enough. The rest can be done with CSS. But you can see here we got something like class mgwt slider. Because GWT is really good at optimizing, we can optimize this as well into obfuscated names. And that's good for 2 reasons. The first one being you can make it smaller. You don't have to have a long class name just to make sure you're not colliding. You can have class names like A, B, C. You can guess how big the application is. I actually took this from. The other thing is you can make sure not to, you don't need to use any deeply nested selectors, which is going to make the matching process between the CSS tree and the DOM tree slower. So fast matching means faster painting. But one of the most important things that GWT can do is dead code removal. So let's take a look at these 2 sliders. They obviously share a lot of code when it comes to moving that pointy thing around. But they don't share so much code when it comes to styling. You can all tell this. So we use CSS resources within mgwt to make sure that only the CSS that is actually used for a specific device, let's say an Android phone or an iPhone, actually ends up on that specific device. And I actually have some numbers on this just to point out how this would compare to media queries. But since we compile once per device, we can make sure that only the Java code or JavaScript code and only the CSS and the resources you actually need end up on this one device. And we practically, because of the GWT compiler, we can remove any unused code there. So another thing you need to get right is you need to have fast layouts. So people think of web applications in the mobile browser that they have to feel sluggish, and that you would get a better application if you just would have the resources to implement it natively, which is absolutely not true. If you want to have fast layout, and that's like a caveat here, you have to never leave native code. And that's, as a web developer, a fairly strange statement to make, because we're never writing native code, aren't we? Well, in a way we are, because the CSS rewrite is somewhat of a configuration for the rendering engine. So once it actually parses that in, it actually does all the stuff in native code. And if you do all your layout in CSS3, which can be easily done with HTML5, using the flexible box model, that is actually runs native, and it is as fast as a native application. The other thing you want to do right is animations. So some people do animations in JavaScript that say with a timer. They do set timeout and then they update the DOM, which is the equivalent of doing something like this. Move it 1 pixel, move it 1 pixel, move it 1 pixel. The only thing a browser can actually do here is repaint. Repaints are expensive, so it has to invalidate the render tree, match against the CSS again, build a new render tree, lay out that, and then build that to the screen, draw that to the screen. If you were just to tell the browser, I want this diff from here to there in 300 milliseconds with a certain timing curve, it can actually figure out a way of doing that fast. And we had a great talk on this in GWT.create in San Francisco, and I encourage you to check this out. Phil Rogers, who used to work on the GWT team, now actually works on the Chrome team and made mobile fly. And he actually builds a whole suite of tools around this, and this is a really good talk, and you can watch that later on YouTube, that goes into detail of what's really important when it comes to mobile performance. But if you tell the browser about this animation, you can do this with CSS. It actually figures out a way to draw a picture, upload that to the GPU, and just move it on the GPU. So no CPU involved whatsoever. And if you look at this, this is what native applications do as well. So this is mgwt in a nutshell. But mgwt can actually do way more than just mobile. So let's take a step back, because to me, starting with Java code means reaching any platform. And today, reaching any platform, you actually need GWT for this, because a lot of platforms just mean JavaScript. And you want to be able to run everywhere. But certainly you don't want to actually write everywhere. So that whole idea of using native SDKs to bring functionality down to phones, it kind of seems off to me. Because there's actually just a small difference between a phone and a desktop application. I'm not saying this applies to every application, I'm just saying it applies to most of the business applications I've seen so far. And the actual difference has just to do with information density and the fact that you cannot give people sandpapers to thin their fingers. So the amount of pixels you can touch with a mouse, that's about 1-2 pixel that the people are exact about this. But the amount of pixels you could touch with your fingers, that is about 30-40 pixels somewhat. So you cannot put as much information on a telephone screen that you could put on the desktop, because people won't actually be able to use it then. So this means that the amount of information per screen varies. So this means that the number of screens is just going to be different. And if you have a different number of screens, this means you're going to ending up having a different navigation. So only two things: screens and navigation. And if you do this properly, you're going to be able to reuse most of your code. You can always optimize for a certain pattern, and if you actually found a pattern, just information density and navigation, you can just optimize for this to be able to use as much code as possible. We've been advocating MVP from the GWT side for a long time. And MVP is a really good thing for reusing code for different platforms, because you're actually isolating a couple of things here. What MVP tries to do, it tries to decouple you from the view. And that's exactly what we need to ship to different devices. So if we are able to replace the view with a mobile, a tablet, or a desktop view, we can reuse the same rendering logic that actually puts data in the view. We can reuse the same UI event handling logic, and of course, the presentation state. So it's pretty important that you structure your applications right for this. Again, only the navigation and the views are different. So if you build small reusable presenters, and you build your navigation in a common place, you can just swap your navigation out and reuse those presenters in a different way. Let me give you one practical example of this. Let's say that's your desktop application that displays some amount of information. Let's try to cut out some presenters. Does anybody have a good idea what a presenter would be here? So okay, the main navigation, this part here, that actually looked like prepped up. But you wouldn't actually guess that this might be a good presenter. I'm going to tell you in a minute why this is a good presenter. Let's just mark them out. Those up here, the tabs, those are a good presenter as well. The formulas here, the form here and there. Remember, it's all about navigation and views. So how is this navigation view actually going to look like on a phone? Well, it translates to a list on the phone where I can just select entries to go to another place in the application. Same goes for tabs. So if you're going to have a tab, that's going just to translate to a list. The forms, they're just going to be forms on a mobile device with proper mobile widgets. Same goes for the other form. And here you can actually see what ended up as our screen for that. That's just one screen on a desktop, and it's several screens on a mobile device. But still, this has been backed up by the same presenters, by the same logic to go to the server to fetch data. It's just got different views and different navigations. And you all know we try to make views as dumb as possible. So it's really hard, really easy to swap them out. It's just navigation and views. So with this in mind, how would you actually build an application? Yeah, well, I would start off with just writing the Java code in MVP style for it and writing tests to make sure I have a proper mock view. Then I would actually bring this application to the web using GWT. And fairly, I can just use GWT for the desktop part. It works fine. As soon as I actually want to go on a mobile phone or a tablet, I'm just going to whip out mgwt, put in some mobile widgets in there, I'm just going to be fine. If I discover at some point I actually need to access the hardware of the device and say I need to take a picture, or I need to read the accelerometer or something like that, that's something I cannot do from a web application. I'm just going to use Phonegap as a runtime container and put my GWT application inside there and distribute it to some app store. And I can do this as well. So that's the main introduction to mgwt and what you could be doing with this. But the main question why most of you, or at least those 30% who already use it, came here is to know what's next for mgwt. And again, looking into the future is always a good way of looking silly later. So this is just my personal opinion. This is not like a Google official roadmap. This is just my thoughts on this, and I want to share this with you. And lots of people have told me that I should drop 10 more widgets in mgwt and then it can do anything they ever need. And I personally don't think so. It's about something completely else here. Well, mgwt is really good for mobile, but GWT has to become really, really great at mobile. And before I joined the GWT team in 2012, I actually had a wish list with me that I wanted to have. I was around the time I was actually starting to contribute to GWT a lot, and I was talking to people on the team telling them, this is what I need. And I wanted to have faster compiles. I wanted to have better debugging support for mobile devices. I wanted to have a more lightweight widget system. I wanted to have good CSS3 support. I wanted to see better runtime performance, and I wanted to see some of the stuff that was in the SDK just killed. I also had a wish list to what to do with specific parts of mgwt. I wanted it to make it easier to extend for you guys so you can actually add functionality to it. I wanted to reduce the amount of work I need to do with a new GWT Phonegap release, because that's always something that a lot of people depend on and it's hard for me to actually do. But I also wanted to see that Phonegap is really, really great on Android. Let's not kid ourselves, before Android 4.4, the browser that you could use in a Phonegap application, that was not so great. But now we actually got Chrome in there, with all the goodness that Chrome can do for you. So let's talk about faster compiles. You all heard this, dev mode is in general a good idea. But this good idea actually is somewhat outdated because you cannot use the same APIs on a mobile device that you could use on desktop before. And this is why it doesn't work on those platforms. It's not that we don't want to make it work, the APIs are just not there. And the whole problem with GWT was we always had this story. The compiler could be as slow, it's just optimizing. But you don't actually have to care about this because you're using dev mode for development purposes. And this is why the GWT compiler has been a whole word compiler that did all the work all the time. And guess what? Being a whole word compiler really sucks in terms of performance. It's good in terms of optimizations, but that's no good when it actually comes to you want to have a fast edit and refresh cycle. And this is why we are actually introducing incremental compiles. You heard about this in Brian's talks, and incremental compiles will make things way faster. There's been a really good talk from Roberto and John about this that actually has been recorded and will be published to YouTube. If you want to know details about incremental compilation, you should definitely check this out. But let me give you some key facts about this. So basically, the idea is that it only recompiles the parts that you actually changed. So this is way less work to do. And just because of this, super dev mode will get much faster because most of the time you're just editing one file, hitting compile, and you want to see that result in the browser. And we're hoping to achieve the same edit and refresh cycle that JavaScript developers currently have. But of course, we also want a better debugging experience on mobile. Remember when the only way to debug in a desktop browser was window.alert? Yeah. In 2011, that was the case on mobile. You won't even give me a proper console they could actually see. But we kind of worked around this in mgwt with having remote loggers. Then there was this really cool tool, Winery, that came up. So we kind of were making things better. But lately, we're actually seeing the faster compiles with super dev mode and the source map support. So this actually means that for the first time, you could compile a GWT application, run this inside a Phonegap container, but still debug your Java code. So eventually, this is going to be solved as desktop is solved today with GWT. It's just going to take a little bit of more work. So I'm actually looking into adding a recompile trigger. Brian basically said this in his talk already, that we need to have an API for you guys to trigger recompiles, just because on a mobile phone, those bookmarklets that we have for Super Dev Mode, they just don't make sense. Where do you actually want to put them? So we need something better here. Maybe you guys, if you're using GWT Phonegap and you're not interested in the accelerometer, we can just use this for a recompile. Shake it once. But the actual tools for developing applications are getting better as well. There's the emulation in Chrome. I don't know if you know about this, but there's just in the dev tools, you can just hit a checkbox that says, I want to be a mobile browser. And then Chrome starts to behave completely like a mobile browser. And you can even set the user. You can say, I'm a Nexus 5, I'm a Nexus 4, I'm an iPhone. And it's not like developing mgwt where it tries to mimic the behavior. It's actually now dispatching touch events. It can actually simulate location. So the tools for actually doing this and developing are getting much better, and you can do most of your development now directly in Chrome. With Android 4.4, they also put Chrome inside of a Phonegap application. And this means that you can now use a remote web inspector. So you can inspect any Chrome tab that's running and do the same kind of DevTools stuff you could do on the desktop. Remove classes, execute JavaScript, do source map debugging. And that's really great. So before, Phonegap could actually not use Chrome. But Chrome is so much better. And this is now finally available with Android 4.4. And so this means that any GWT application has become so much better when it runs inside a Phonegap application. I also wanted to see a new lightweight widget system. And I kind of talked about this in my web components talk, where I said, well, the widget system was actually designed around two assumptions. You cannot extend DOM elements. That's kind of solved with web components. And we need to solve memory leaks. Modern browsers actually don't have memory leaks anymore. So why not have a much thinner layer as the notion of a widget? Because today's widgets kind of introduce a lot of code. They, for instance, have a dependency on hash map, and they have a dependency on array list, so they pull in a lot of code that you would actually not need. And I think Elemental is actually a really good start for this, but it misses like a certain degree of being able to write things. And web components are much better at this, and frankly, you just saw the talk. We're bringing web components into GWT, and therefore into mgwt at some point as well. The other thing I was concerned about was CSS3 support. And CSS3 support means, yeah, well, you all know this. The flute parser that we do have in GWT, that's not working really great. It was actually made for CSS2, and we kind of botched it up and make it work with most of the CSS3 stuff, but most of the times it was just a pain in the ass to use. You had to escape all kinds of things, and if you ever looked at the implementation of the mgwt CSS, it was sometimes horrible. So with the new GSS resources that Julian introduced this morning, you will now be able to use any CSS3 features within a GWT application, and therefore within an mgwt applications. Let me give you one example where this is important. Let's take a look back into the mgwt slider. Actually, this is basically randomly picked. I'm not picking the slider specifically because it's way better at this. I'm picking it just because it's just like a small widget. If you add up all its CSS, this adds up to about 8 kilobytes of CSS for all the different platforms and making it work across all the different browsers. The recompiler looks at this and splits it up by several permutation properties. It uses the user agent for distinguish between, let's say, a -webkit prefix and a -mods prefix. But it also uses a platform that is platform permutation that's introduced by mgwt, which is like iPhone Retina or iPhone not Retina, or an iPad, an Android phone, and so on. So remember this. This is 8 kilobytes of CSS. If you don't do anything to it, if you were to implement it with media queries. And if you use the GWT compiler for this, this is 734 bytes. This is more than a factor of 10. So if people ask me about media queries and why we don't do responsive design, that's why. Because responsive design tends to be that much slower. It's acceptable for some websites, but it's not acceptable for a fast, well-running application. You don't want to ship the CSS for the desktop, a tablet, and a phone to a small, tiny feature phone, and then make it decide on which CSS it actually needs. That's something you do in a compile step in advance. I also wanted to see improved runtime performance. So if you look today at ArrayList versus JS Array or HashMap versus JavaScript object, there's some performance difference in there. And you would normally expect that the ArrayList should be on par with the JS Array. They should be about the same level. There's some different semantics that you have to implement in Java that are expected, like an index out of bound exception that makes things a little bit slower, but generally that should be about the same level. The problem is most of the collections were actually written when GWT started, and there were decent assumptions about browser performance. And most of the stuff was written the way it was written to make it acceptable by 86. And recently, browsers have changed. They make actually different assumptions about JavaScript. The really good news about this is that the JavaScript that is well written in terms of types actually runs fast, because this is how V8 internally, and this is how SpiderMonkey internally actually operates to make JavaScript fast. The whole dynamic part of JavaScript, where you can just do dispatching into any direction, that's actually not running fast. So having that kind of class structure we got actually should help us a lot in running fast. But as it turns out, we are violating certain assumptions in certain places. We can actually fix up the GWT compiler to make this much better. So this is why we actually added profiling capabilities to D8. Well, D8 is the command line version of V8. And in D8, that's a profile. You can run your JavaScript through you, and it actually tell you a whole lot of bunch about this. I'm not going to go into detail on how this works. There are good talks from the V8 team and the Chrome team about how to use it. But I want to show you one example of one kind of bug we actually had to hunt down in Google Spreadsheets. So two things. There's now a linker in GWT. You can use that. That targets specifically D8. And we also added source map support into V8 to make sure that you guys are actually getting back a proper profile. So let me show you how that works. So I have a simple example with me here. I'm having an array of integers, so just numbers. And I'm just doing heavy calculations on that array. I'm just summing it up here. And then I'm hiding the actual value from the GWT compiler by just assigning it to a global variable. That's just, so it doesn't optimize the whole for loop out of there. So and I'm creating the array in a way where the V8 engine actually thinks that this is a sparse array instead of a dense array. And it's actually not being backed up by a CLUG structure, it's actually being backed up by a hash map. Let me show you how you can find such a bug with a profiler. So I'm just gonna, actually compile that real quick. So what's important to know about arrays, you could create a new JavaScript array and assign to, to the place of 1,000,000, you can assign an integer there. So the browser could, of course, allocate a complete array with 0 to 1,000,000 places and put your value in there. But that's going to consume a lot of memory, isn't it? So it's actually going to assume if you just assign to 1,000,000, you're actually meant to have a hash map there because your code is somewhat broken. And you know, if something's broken in JavaScript, you're just going to continue until it really breaks. So, and that's actually some assumptions in V8, and they're somewhat similar in SpiderMonkey as well. So if you're assigning more than 1,023 values after the last array index that has been initialized, it actually changes the array to be a sparse array. So let's say if you want to make room for lines in a spreadsheet, and that's more than 1,000 lines, you could actually change your underlying data structure to not be fast anymore. And that's what this is about. So this compiled. Let's quickly move this over into working directory. So what I have here now is the actual boot up script, the compiled application, and a source map file. And we're going to get into that source map file in a second. So I actually have V8 compiled locally with the D8 shell in my path. So I can do something like time D8, please profile me that JavaScript. So now the profiler is kicking up and it's running. It's just going to take about, I don't know, 5-6 seconds. There it is. So it actually produced an output file called V8 log. And there's lots of very useful information in there. And I'm not going to go into detail now. That's just going to blow the scope of the talk. But there's actually something called the tick processor that can actually analyze these and build a drill down of what happened here. And here it is. So you can see it spent 44% executing a function called named FC, which is not really helpful because we don't know which actual Java function this has been. But it also did 30% of the time a keyed load IC. And it did 25% a stub of value of nan, which seems kind of off. Most of the times we actually would just see it executing our JavaScript at 99% of the time, because these things here mean it has not been executing our JavaScript. It has been doing something else to support the execution of our JavaScript. And that else is actually moving stuff around in that hash map. So let's actually just change. We're not going to change anything to the actual program that consumes time. We're just going to change something to the creation here. And just create this array differently. So let's create it as a really good array, where just values go from 0 to the end of the array. Same values in there, nothing. Oh, let me quickly, before we actually do this, show you. So you've seen the function that's actually been called here, and you cannot make sense of this. So I've introduced a new parameter to D8, where you can just say -source-map and hand it over the source map. So, and it actually rebuilds the profile now. It rebuilds the profile now. Oh, sorry about this. This was wrong. So this rebuilds the profile. Instead of funky looking JavaScript functions, we can now actually see where it spends its time. You can see it's the entry method holder, line 22, first tool. And in this drill down here as well, we can see impl and all the other Java classes we would expect. And this actually helps you to find where your program is spending time. So let's go ahead and compile the real working example. So let's profile this again. So you can instantly see this runs much faster. It's only 1.6 seconds instead of the 5 something. Then if you take a look at this, it now actually executes our JavaScript 97% of the time. And actually now spends all of its time in profile.java line 32. And that's right, this method here, where you actually would expect it to spend its time. So this actually helped us a lot in drilling down to specific performance problems and actually finding hotspots where you don't actually need to expect them. So there are a couple of unexpected things. For instance, if you have a try-catch block, V8 will actually not optimize the code in the try area. So this means that runs slow. We can actually do stuff about this pretty easily. There are other things like instance of sometimes tends to be slow or being much more expensive than you would expect it to be. And that's actually a good way of finding these hotspots in your program. Let's switch back to slides, though. So, actually improving runtime performance also means that we have to make sure that once we actually improve runtime performance, that we're actually going to keep this runtime performance. And that's why we're going to add a benchmark suite to GWT to actually track our performance based on every commit. So this is supposed to work. You have a baseline and you have the actual commit. So you just run both and just compare them. So you're gonna get noise and all that stuff mostly out of the way. Then this means that we can also start modifying the compiler to be clever in output. So we can just modify the compiler to do asm.js annotations on your code and actually see the impact and the benchmarks directly. And maybe this will add up to specific V8 or SpiderMonkey passes that just make your JavaScript magically faster on these engines. One of the other things we need to do is we need to remove cruft from GWT. So the whole permutation system was built around the assumption we need to get IE6 working with the rest. And they basically look like this. But today it's actually more like Chrome, Firefox, and IE 11 versus the rest. So we could go for, I'm not saying this as a roadmap, but a good idea could be to go for a modern permutation and a quirks permutation. And that would actually kill a whole lot of legacy. And that's pretty important because you're actually feeling that legacy sometimes on mobile devices. One good example of this is the history implementation. It actually used to have a timer in there that was actually looking at the token there for Safari, which does not make any sense for an iPhone or an Android phone, because their actual registration for window on hash change just works perfectly. There's some other things I want to see being improved in mgwt. We want to make mgwt more extendable, and we actually want to make all the widgets experience-based. So this means that you can change out the DOM and the CSS as you like to, and only the actual logic of a widget is bound to your Java code. All the layout inside of mgwt has to be updated to use the newer version of the flexible box model. And there's already people there that build a sufficient amount of Windows Phone support into mgwt, and it's just a matter of actually merging that into trunk. And one of the obvious things to do is, of course, upgrading mgwt to actually use GSS files instead of CSS resources. What I love to see to be done to GWT Phonegap is to actually change it to be auto-generated. So right now, this is a lot of pain in updating it. I always have to keep track of what the Phonegap team actually changed. And I just want it to be auto-generated in the way that Ray was talking about zero work JS interop. So I already talked with the Phonegap team about this, and they would be perfectly fine with us adding JS doc annotations to their JavaScript in order for us to be able to do this kind of work. Because for them, that just looks like better documentation, and they can better generate their documentation for this. And we should be adding linkers to GWT Phonegap that enable you guys to directly output your Phonegap application from a GWT compile. Well, there's going to be a new mgwt release that's completely done. I'm just waiting for GWT 2.6 so I can actually build against this. GWT 2.6 actually changed a couple of things. So this means that mgwt currently, the trunk currently works with GWT 2.6 RC3, but if you compile mgwt, the version 1.1.2 against GWT 2.6 or the release candidate, it just does not work. It also includes a new swipe menu that is actually being used by a product at Google. The DoubleClick team from ads actually uses it, and it has a lot of bug fixes in there. So the good news is we're actually now using mgwt into production. We're actually using that in production. And that's actually going to be a new GWT Phonegap release, which is hopefully the last we have to do by hand. And that's basically waiting for GWT 2.6 as well. So let me open up for questions. But also let me thank you guys for your attention. If you want to stalk me, thanks. Any questions?
Will there be any performance impacts if we use the Shadow DOM? I think they are ready for use in all mobile platforms right now.
I actually don't know about Shadow DOM on Safari, mobile, and Android. Why do you want to use the Shadow DOM?
I'm asking because the actual DOM I think, is smaller if we encapsulate it within custom tag.
Is it? So you're saying the actual reflow it does is smaller depending? I don't know about this. No idea. That's something that's definitely worth looking into, going into the future, but I'm not sure now. There was some question over there. Mike is coming.
I saw in Android 4.4 that debugging package Phonegap app is really simple, but what about iOS and older Android apps? Because we can't debug in WebView.
I didn't get the question. What's the actual question? You
How
saying
can I debug a package app in Phonegap in WebView in on older Android and iOS? Because I can't be in debug.
So you're saying you can debug an Android application just fine, a Phonegap application running on Android just fine, but you're having trouble with iOS.
All works fine in Android 4.4, the last, because we can be in debug in a WebView, because that's based on Chrome, and I can use Chrome remote debugging, but not on iOS. Is there a solution?
So Apple actually has a tool chain for remote debugging the JavaScript in there. So you're just going to touch your device via USB, and actually in Safari there's a tab where you can just have a remote inspector similar to the Chrome developer tools. So there's a solution for this.
Yes, but the JavaScript is compiled, so we can't really understand what's going on in. We can see our logs, but that's like the old school with alert and console.log.
So you're saying you're missing the source mapping there. So I would actually do most of my development just because of the source mapping right now on Android. But at some points, I definitely have to look at how the application actually behaves on iOS. And if it's just running fine, you're actually not going to debug. So I wouldn't spend that much time debugging on iOS. But if you definitely have to just compile pretty, then you're going to make a good sense of what's actually going on. Okay. I think behind there we got someone. Maybe we should just throw the mic. I think it's coming.
Yeah, I just wanted to know if mgwt is already integrated in GWT platform, or is it add-on, or is it plug-in?
So
How to use it?
So mgwt is currently not integrated into GWT source code. It's just a simple reason. There's no reason to tie it to any GWT release cycles. We can evolve it separately from the GWT SDK, and the GWT SDK is just going to be released twice a year. We can actually move much faster here. It's just an open source project. If you go to m-gwt.com, there's a whole bunch of stuff there that's going to help you get
download
started.
it and put it.
Yeah, it's a jar file. You can basically
Okay.
just, if you know how to use other projects, you should mostly be fine.
Okay, thank you.
As you just said, you're gonna update Phonegap to version 3.2, and we, as of now, are using the old version with Phonegap, obviously, and we got a couple of private Phonegap plugins we wrote, and we don't own them. The customers do. So we can publish them to the public repository of Phonegap. So are we stuck with the old Phonegap versions, or are there plans that private repositories will be made available with Phonegap 3 in the future? Do you know anything about that?
Yeah, that's basically a question for the open source Phonegap project.
Yeah, you have more insight on that, so I thought maybe you have some.
No, I don't know
information on
about their exact plans and how their build system is going to work. I am in touch with a couple of people from the Phonegap project, but that's a detail I'm not aware of in any way. No.
that. Okay, thank you.
Okay, thank you.